Hello again. We're back at Unit 6, Section 2. This is the bottom of page 4. So off we go. We're going to practice and try to figure it out what they mean about describe the end behavior of the following functions. So the only thing I have here is the function. So a couple things that matter. One is the leading coefficient. The leading coefficient right here is positive. Also, the degree. The degree right here is even. So I'm going to look over here. So I'm going to look at even functions, and leading coefficient is positive. So it's going to look like this. So both ends go up. Both ends go up. And I also know it will have 3 extrema, or 3 turning points. So it's going to look something like this. So the way you write your answer is when we're trying to determine the end behavior. So off we go. As x approaches negative infinity, so we're looking at that. Then f of x approaches positive infinity, right there. And at this point, I already know they both ends go to the same place, or both ends go up because the leading coefficient is positive. So then, as x approaches positive infinity, this guy, then f of x also approaches positive infinity. I think sketching the graph is good for you. Now the next one, the degree is 3, so odd. The leading coefficient is 1, positive. So positive, think about positive slope. Positive slope goes up like this because it's an odd function. So again, odd function. The left side goes down like this, and the right side goes up like this. So as x approaches negative infinity, then f of x approaches negative infinity. We're looking at that, or looking at that. Now the other side, as x approaches positive infinity, I'm looking at that. As x approaches positive infinity, then f of x approaches positive infinity, right there. The next one, I have a negative leading coefficient now. Negative leading coefficient in an odd function. So I think negative slope is going to look like this. So my left side is going to be like this. My right side is going to be like that. And I'll have 4 extrema. If the degree is 5, it's always 1 less than the degree. 1, 2, 3, 4. So off we go. As x approaches negative infinity, that guy, then f of x approaches positive infinity. As x approaches positive infinity, this guy, then f of x approaches negative infinity. Now we're working backwards. We need to select all the apply. So as x approaches negative infinity, so it looks like this, then f of x approaches negative infinity. Okay, that's the first statement. As x approaches positive infinity, then f of x approaches negative infinity. So they agree. So first thing I know is they're opening down, so they go down. That means the leading coefficient is negative. And it's also even because they both open the same direction. So this one is odd, so I'll mark it off. This one is even. Okay, it has potential. However, it should be with a negative leading coefficient, and that's not the case. The next one, negative leading coefficient and even degree 4 right there. The next one, the leading coefficient is positive, so goodbye. Next one, negative leading coefficient, that's good, but we're looking for even degree, and 7 is odd. The last one is negative leading coefficient, so that's good. Also, the degree is 2, so even. So we have this and this one. They're both true. All right, page 5. So when f of x is a polynomial function and a is a real number, so a, remember, is the leading coefficient. then the statements listed below are equivalent. So when x equals 0, not 0, a. When x is a is a 0 of the function, because that means your graph is crossing the x-axis right there, 0 of the function, x-intercept. When x equals a is a solution of the polynomial. So x-intercept could be called zeros of the function or solutions of the function. They're both the same thing. So f of x equals 0, that means y equals 0. So x minus a is a factor of the polynomial. We will do a lot of the factors, but we already know from the previous lessons that when you set the factor equal to 0, you can solve to find the x-intercepts or to find the solution to your function. Now, a number, a, 0, is always going to be x-intercept on the graph. So the x-intercept is every time that y equals 0. And then whatever this number is, a is going to be that number for the x-intercept. We're going to see if we can find a pattern here. So here I have the function, and this graph represents this function right there. I see 4 right there, but this would be -4. I see 2, and I see 3. Because I already know how the factors and the x-intercepts relate. Okay, I can't help it. Now, I already know -4 right there, 5 right there, and 2 right there. Look at this point right there where 2 is, that it doesn't behave the same way as they do at 5 or at -4. Okay, well, let's just pay attention to that, what it looks like right there. And look at the degree. Let's look at this one. We have -3, I have 2, and 5. Look at the degree of that is different than that, and they also behave differently. This guy, they're all acting the same way. So nothing to see here, folks. Right here, 2, 5, and -4. Look at this. Look at the degree. Look at the degree. They kind of look the same. Right there, -4, 2, and 5. But look at the degree right there. So we know that the degree that the factor is right there, they behave differently. So when it's just power of 1, like these guys right here, they have the exponent right there, invisible 1. They simply cross the x-axis. So when the degree is 2, it bounces off the x-axis. Sometimes bounces off to go down, or sometimes it bounces right there to go back up. But when the degree is 2, it bounces. When the degree is 3, it's like it crosses and slides. It's cross and slide, just like here. It crosses and slides. Okay? But these are some things that you need to remember when you're graphing. And then I'll definitely have to make a separate video for the last page, or I might just do it in person when I come back.